Okay, we're still talking about the fundamental theorem of calculus, and in this video we will go through 3 examples that all involve integrating a sine function. So the first one is here. Find the area under the graph of y equals sine x from x equals 1.1 to x equals 2.5. Okay, here we go. The area under the graph that we're looking for is going to be the integral from 1.1 to 2.5 of the sine function. So the integral of sine x dx. Now this is not hard. You just have to be careful not to get the negative signs mixed up. When we integrate sine x, what do we get? Well, the integral of sine x is negative cosine x. So this is negative cosine x evaluated from 1.1 to 2.5. So this means negative cosine of 2.5 minus negative cosine of 1.1. Negative cosine of 2.5 minus negative cosine of 1.1. Okay, on the calculator, the cosine of 2.5 is negative, so we have negative 0.8011, and I get that number just from doing cosine of 2.5 on the calculator, minus negative cosine of 1.1, and the cosine of 1.1 is positive 0.4534. So this ends up being positive. This is a positive number because of the 2 negative signs, and that becomes a positive. So it's 0.8011 plus 0.4534, and we get 1.2547. And that's the answer. Now what we just found was this. Let's make a little sketch. The sine function looks something like this. Okay, and it continues obviously, but this value right here where it touches, that's pi. So 1.1 roughly would be about here, and 2.5 would be about there. So what we have found is the area under the graph of the sine function between those two values. So that's the area we just found. And it's 1.2547. All right, now let's look at the next problem. For the graph of y equals sine x, find the area under the first half cycle. So this is what we're looking for now. A quick sketch here. The sine function does this. We're just looking at the first half cycle. Remember, that's a complete cycle. The up part and the down part is a complete cycle. We're just looking at the first half cycle right here, and we're looking for this area. So what are these x values? Well, this is x equals 0 right here, and this is x equals pi. So we're trying to find the area under one piece of a curve there. And so this is going to be the integral, the area here will be the integral from 0 to pi of sine x dx. So let's do this. Well, the integral of the sine function is the negative cosine function. So it's negative cosine x evaluated from 0 to pi. So it's going to be negative cosine of pi minus negative cosine of 0. And we can do this. We know what the cosine of pi is. Remember on our unit circle? Pi is half of a rotation. Pi radians gets us to this point right here. And the cosine right there is negative 1. So this is negative 1 minus negative cosine of 0. And 0 is right here. And the cosine there is 1. So minus 1. So look at this. This is a positive 1 plus 1 right there. And that equals 2. How about that? The area under one piece of this curve right there is exactly 2. And I want to add that I personally think that that is pretty amazing. This is one of many things that we find in math that is just beautiful and amazing at the same time. These sinusoidal functions are just so perfect. If you look at this graph, the slope right here is exactly 1. The slope right there, the peak is exactly 0, of course. The slope right there is exactly -1. And the area under one section right there is exactly 2. Pretty cool. Okay, now let's look at the third problem. The third problem in this set is instructive. We're told to find the area under the graph of y equals sine x from x equals 0 to x equals 4. So that's going to look like this. Let's make a graph. And the sine function is going to look something like this. And let's put some values on here. This is an x value of pi. So this over here is 2 pi right there. So 4 is going to be approximately here. And we're going to find the area from 0 to 4. So we're looking for this area. Okay, what will that be? Well, pretty straightforward. It's the integral from 0 to 4 of sine x dx. So we integrate the sine function and we get the negative cosine of x evaluated from 0 to 4. So this will be negative cosine of 4 minus negative cosine of 0. Cosine of 0. Okay, and what is that? That's negative cosine of 4. Well, cosine of 4 is a negative number. Cosine of 4 is, if you do that on the calculator, you get negative 0.6536. So negative cosine of 4 comes out to be positive 0.6536. And then minus a negative right there becomes a plus cosine of 0. And cosine of 0 is 1. So this comes out to 1.6536. Now, that's not a problem. That's the answer, and that's correct. But think about this for a second. This number 1.6 something, that's smaller than the number we had in the earlier example. Look at this. Remember this one? If we were just going from 0 to pi, we had an area of 2. And now down here, on this example, we're going over further. We've got this additional piece of area down here. So you might expect the area to be larger than 2, and it's not. It comes out to less than 2. And the reason is this area here below the axis, the integral calculates that as negative. So what it's doing, it's taking this area here, which is 2, and then it's subtracting this much from it. And we're ending up with 1.6536. And that's important. It's not hard, but it's important. Just realize that area above the axis is considered positive and area below the x-axis is considered negative. And when you evaluate the integral, it naturally evaluates that way every time. So you might want to make a note of that on your page there. That is negative area. And up here is positive.